All right, let's take a look at question number 1. So question number 1 said find the area of the shaded region. So this is the shaded region. So you can see that there are 3 graphs involved over here. So you had the line y equal to x in the curve y equal to x squared over 4 and the horizontal line y equal to 1. So this is the shaded region. So we only learn find the area that is enclosed or bounded by 2 curves. So we can chop this into 2 parts. So if I call this R1 and this is R2, then you will find out that R1 is bounded above by the line y equal to x, and then below by the curve y equal to x squared over 4. The interval is 0 to 1. And then R2 is bounded above by line y equal to 1 and the curve and below y equal to x squared over 4. So we can separate this into 2 parts, R1 and R2. So we are going to say the area of shaded region equal to R1 plus R2. So now let's find R1. So R1, the top function is y equal to x. The bottom function is y equal to x squared over 4. So integral, the top is x, bottom is x squared over 4. So A and B are going to be the smallest x value and the highest x value. So you can see it is 0 to x equal 1. So that will be R1. And then R2. This part is R2. The interval is from 1 to 2. So 1 to 2. And then for R2, the top is the function y equal 1. And the bottom is y equal to x squared over 4. So top function minus bottom function. Okay, so now we have the 2 integral. So the next step is we are going to integrate it. So we're going to have the x squared over 2 and minus, I want to put the 1 4 in the front, so x squared become x cubed over 3. And then bracket 0 to 1. So let's simplify a little bit. You get x squared over 2 minus 1 over 12 times x cubed, because this is 1 times x cubed and this is 4 times 3. So now we're going to have 1 over 2 minus, this is going to be 1 cubed is 1 over 12, and then minus 0. So we're going to find the common denominator 12. So this is 6, this is 112, and then you can find 12. So R1 has an area 5 over 12. Now let's go to R2. So over here, we got 1x minus 1 over 4 times, this is x cubed over 3, just like this one. Now we're going to have the interval 1 to 2. So you're going to have 1 times 2 is 2 minus 1 over 12 times 2 to the third power, subtract. 1 times 1 is 1 minus, this is 1 over 12, and then you have 1 to the third power. Now we're going to simplify. So 2 minus e over 12 minus, this is 1 minus 1 over 12. And then I'm going to find the common denominator. This is 12, this is 24 minus 8, 12. And here you got 11, 12. So you're going to continue to subtract. So you're going to get 16 over 12 minus 11 over 12. So you get 5, 12. So therefore at the end, area of shaded region equal to 5 over 12 plus 5 over 12 equal to 12, and you simplify it is 5 over 6. Okay, so R1 is 5 over 12, R2 is 5 over 12. Add them together is 10 over 12. So therefore, you simplify is 5 over 6. So we found the area of the shaded region by using two separate integrals. Now let's take a look at question number one more time. So some people may say there must be another way to do it. So let's use another method to do number one. Okay, so I'm going to sketch this over. Okay, so now do you see a trapezoid over here? So we can use the regular formula to find the area of the trapezoid and then subtract the area underneath the curve, y equal to x squared over 4, running from the 0 to 12. There's that. So trapezoid. Minus okay, so our plan is using the area of the trapezoid, subtract the area underneath the curve, the y part, and then we get the shaded region. So the area of the trapezoid, we're going to find the base 1, base 2 here. You get 0 to 2 unit. And then here you get 1 to 2, so this is 1 unit. The height is 1. Okay, so this one, you get from 0 to 2, the graph is y equal to x squared over 4. So now we are going to do 1/2 base 1 plus base 2 times the height to get the area of this one. Because this part is irregular shape, is under the curve y equal to x squared over 4. So we're going to use integral 0 to 2. It runs from 0 to 2, and the curve is x squared over 4 dx, and equal to the area of the shaded region. Now over here, we're going to do 1/2 base 1, base 2, 1 plus 2 times the height. So we're going to continue, so you're going to get 3 over 2. And this part we're going to integrate, so we're going to get 1/4 times the x squared will become x cubed over 3. And then evaluate from 0 to 2. Okay, this is minus 0. So if you want, you can put the braces, but it's because it's 0. If you don't do it, it doesn't change the answer. So over here, you got 1 over 12 times 2 to the third power. So you continue, so you get 3 over 2 minus, basically you got 8 over 12. And then we're going to find the common denominator. So this is going to be times 6 and times 6. Okay, and then you simplify it, you're going to get 10 over 12, and then at the end, 5 over 6. So we found the same answer. Okay, so we used two different methods to solve question number 1. Let's take a look at question number 2. All right, question number 2. Let R be the region bounded by the graph y equal to sine pi x and y equal to x cubed minus 4x as shown in the figure. So part A, find the area of R. And part B, the horizontal line y equal to -2 split the region R into two parts. Write but do not evaluate an integral expression for the area of the part R that is below the horizontal line. Now, for this question, we're definitely going to use the calculator. So even though the graph is given to us, so you are going to use a calculator to find the answer. So now we are going to type in okay, so let's go to type in the equations. Don't forget to let your mode be in radian mode. So you get the sine pi x, okay? So I'm going to type in sine pi x as my y1. And then I have x cubed minus 4x. Now I am going to set my window. So let's take a look at the graph over here. So it's 0 to 2. So I'm going to set my window 0 to 2. And then I am going to make my scale counter by 1. The y min, y max. If you use -10 to 10, it's good. But if you look at the graph over here, the highest number is 1. So you may want to use a smaller window for the y min and y max. So I'm going to use -5 to 2. That will cover. So I'm going to press graph. So you can see that my y1 definitely will be the sine function, and my y2 will be the cubic function. So now over here, the graph already gave you the intersection would be 0, 0 and 2, 0. So therefore, to find the area of the shaded region R, or the area of R, this entire thing is R. So what we are going to do is area of R equal to integral, because your smallest x value is 0 and your biggest x value is 2. So 0 to 2. Top function. The top function, this is the sine function. So you're going to have sine pi x and minus. This is your bottom function. That is a cubic function. Don't forget to put that inside the parenthesis because you are subtracting two terms. So your x cubed minus 4x and then dx. So now we're going to use a calculator to do this one. So you're going to go back to the main screen, do math 9, 0 to 2, and then you do y1 minus y2. dx. And then you get 4. So therefore the answer is 4. So part A. Now let's take a look at part B. The horizontal line y equal to -2 split the region R into two parts. Write but do not evaluate an integral expression for the area of the part R that is below the horizontal line. So where is the horizontal line y equal to -2? It's not given to us. So that means we have to draw it. So we're going to draw it. Okay. So this is y equal to -2. And you can see that we split the region into two parts, the top part and the bottom part. The question asks you to write an integral expression for the area of the part that is below the horizontal line. That means it's this one, this part over here. Okay, I'm going to call it R1. So for the R1, the top is the horizontal line, the bottom is y equal to x cubed minus 4x. So now I know my top function and my bottom function, but what should be the smallest x value and what should be the biggest x value for the intersection? So we need to find it because they are bounded from here to here. Now I'm going to use a calculator. So we go back to the y equal. So I don't need my sine function. I'm going to unhighlight. I'm going to y3. I'm going to type in -2. Now I'm going to graph. Okay, now you can see it. This is y equal to -2. This is y equal to x cubed minus 4x. We are going to find the intersection. So the intersection for the first one is here, 0.53918887 comma -2. And then this one, okay, it'll be something comma -2. So let's find, so 5. And then you're going to so we found that it's 1.675 1309. Okay, so now we found our smallest x value and the biggest x value. One more time, the a and b for the integral had to be the smallest x value and the biggest x value that is shared by the two curves. So it had to be these 2 points, had nothing to do with the 0 and 2, because this is your R1. Okay, your R1 begins at the 0.5391887 and stop at 1.67511309. So now for part B. So the area of the region, okay, I call it R1. It begins at 0.5391887 and stop at 1.67511309, and on top is -2, and then you subtract the below, x cubed minus 4x. So this is going to be the integral. If you're interested, you can calculate. But the question asks us write but do not evaluate. So we finished question number 2.